Greetings, I'm Mr. French, and this is topic 3.4, Differentiating Inverse Trigonometric Functions from the AP Calculus AP Classroom curriculum. Now, I'm not going to spend a lot of time deriving these functions or these derivatives, so here they are. In particular, you most likely want to focus on the derivative of sine, the derivative of cosine, and the derivative of tangent. These others might show up, but most frequently I have found that these three are the derivatives that they tend to ask about on any of the AP tests. So the derivative of the inverse of sine is 1 over the square root of 1 minus x squared. And the derivative of the inverse cosine is the same expression, but just with a negative sign. And then our derivative of the inverse tangent is 1 over x squared plus 1. So let's keep those in mind as we go over a couple of examples. So our first example is the derivative of the inverse secant. I did say to focus on the others, but I might as well throw one of these in as well. So the derivative of the inverse secant of e to the x. When we look, I hope you see that we are dealing with a composite function here, where e to the x would be my inside function, and the inverse secant is my outside operation. So I will take the derivative of the inverse secant according to my table over here, where x is now the inside function, e to the x. So my derivative will be a fraction, 1 over the absolute value of x, but x is my inside function, so e to the x. I don't really need the absolute value because e to the x will always be positive, over the square root of x squared, where x is e to the x, so e to the x squared minus 1. And then I have to finish my chain rule, so times the derivative of e to the x, which of course is just e to the x. Now, I can simplify that pretty quickly because I have an e to the x in the denominator and an e to the x in the numerator. So my derivative ends up being 1 over the square root of e, and I can even say to the 2x minus 1 as my derivative. And there we go. Let's look at another example. Okay, now I'm saying that my function f of x is going to be the arc cosine of x, but the arc cosine is really just another way of saying the inverse cosine. And then I'm asking for what this limit is as x approaches 1/2. I really hope by now that you recognize that this expression isn't really asking for a limit, it's actually asking for the derivative of f as x is equal to 1/2. So these two expressions are actually the same. To find this derivative, I need the derivative of the inverse cosine. Well, the derivative of the inverse cosine from our chart over here, eventually you'll want to memorize it, is negative 1 over the square root of 1 minus x, but x is going to be 1/2 in this case, squared. Well, 1/2 squared is 1/4, so this becomes negative 1 over the square root of 1 minus 1/4, which becomes negative 1 over the square root of 3/4, which eventually simplifies to negative 2 over the square root of 3. And we check our answer. There it is. And that's about all we're going to spend time on for the inverse trigonometric functions. Again, these are nice to know, but as far as the frequency they appear on the AP calculus test, they show up a lot less frequently than some of these other topics. So, nice to know, but questionable as to how necessary they are.